Welcome to my model storage robot project. In this video, I'll give you an overview of the project, what I have in mind, what I'm planning to use, and what the intermediate steps will be. Perhaps I should say what the intermediate steps might be, because as I'm recording this, I've only completed the first stages of the project, so I don't know yet how far I'll get in the end. Nevertheless, I'd like to invite you to take a look at the big picture and get an overview of what I'm intending to show in the upcoming videos. Now, what is a storage robot? Here's a look at the inside of one. This robot is used to store and retrieve boxes that contain various media in a library. Here's another example. This one is a tape storage robot, also known as a tape library, filmed by Peter Kranz. Storage robots have a wide range of applications nowadays, ranging from small 19-inch tape libraries to roughly room-sized automated storages used, for example, in pharmacies, up to high-rise storage systems of truly enormous proportions. They present a fascinating range of challenges: the hardware design and build, the low-level control software, and the higher-level management applications. Now, I do have a professional background in software engineering, but so far I haven't worked with storage robots of any size, so I decided to build one of my own. I'll be using this project as a kind of playground to try out various technologies that have been lingering on my list of things to check out someday, because I prefer to have a slightly more realistic application scenario when trying out new stuff. After all, you can only learn so much from an application that simply prints "Hello World." Of course, in order to create software and applications for a storage robot, I need one. And since these things are neither cheap nor small, I'll have to build a model of one myself. To build the actual machine, I'll be using a system called Fischertechnik, which was first released as far back as 1966 and has been improved and extended continuously to this day. The first computer interfaces were sold around 1985 for computers that some of you might only know from a museum, including the Apple II, the Acorn, or the C64. This image shows a fairly modern construction, built using a kit named Industrial Robots. Although this isn't the latest version of that particular robot, you get the idea. My intention is to describe the hardware and the process of building it in detail in the next video. On the right-hand side of the model, you'll notice this box. It's called the Robo Interface, and it contains a 16 MHz microcontroller. Yep, megahertz, not gigahertz. 128 kilobytes of RAM, again kilo, not mega or giga, and the same amount of flash memory to permanently store programs. It can be programmed to work autonomously without a computer attached. This isn't the most modern interface available. In fact, there are two newer models available on the market, but I don't have these, so I'll stick with what I've got. Also, working within constrained environments tends to make projects like these more interesting. As you might note, the robot shown here uses up pretty much all of the input and output lines of the interface, and for my project, I need some additional sensors as well as means to communicate with the robot. Therefore, I'll be throwing in this red box, which is called an extension module. It can be connected to the Robo interface and controlled by it. It also has a USB connection and can be controlled from a computer, but it doesn't have the capability to run programs on its own. So this is the hardware side and a hint of the low-level software. Let's move this out of the way to make room for the big picture I promised. As I already said, the Robo interface can be programmed, but its default programming environment is a bit special. It's called Robo Pro, and it's a graphic programming environment. It's certainly good as an introduction to programming and for teaching, but if you want to know whether developing complex programs by drawing flow diagrams is more fun than writing lines and lines of seemingly boring code, just watch the video I'll be sharing. As you might get from the specs, the Robo interface isn't really suitable for running a complex software solution, and we'll get to complex in a minute. In fact, it's not even that easy to control the robot from an external application at all, since, unlike the newer models, this Robo interface doesn't have ready-made external communication interfaces, so I need to make one. This is a device called a photon, made by a company called Particle, formerly known as Spark. Note that this image is not to scale. This is actually a very tiny module that not only contains an Arduino-style microcontroller, but it also has a wireless LAN interface and thus can be connected to a network. Even more interesting, it comes with a built-in capability to connect to a cloud-based system that provides both convenient device management and programming facilities, as well as an API to interact with the programmed device. The Photon has a larger cousin called Electron for cellular mobile communication, but for this application the Photon will do just fine. There are a number of similar devices on the market at the moment. I've chosen the Photon for its availability at a very reasonable price and the functionality and documentation of its cloud API. The Photon is programmed using a language that is similar to C, but contains some C++ elements as well, hence this C++-ish bubble here. You may remember that I mentioned a complex software solution earlier, and for complex solutions it's always a good idea to turn to SAP. I actually work with SAP NetWeaver based systems on a daily basis, but as I've said, I would like to use this project as a playground to try out some libraries and technologies that I haven't had the chance to use in my professional work so far. I'll be using the SAP NetWeaver application server ABAP, so ABAP is the main programming language for the backend logic. Note that I'll be relying on the application server ABAP only here. I probably won't be using things like the HANA Cloud Platform, at least not for the first steps, because I specifically want to try out some new features of the application server introduced with the current version 7.50. The first thing I will need to do is get access to the Cloud API and wrap the features implemented in the Photon into some kind of device management and access package. Triggering functions and synchronously fetching data from the device is done through a REST-based API of reasonable complexity. However, for this application, I also need to consume event notifications triggered by the hardware. These events are available using HTTP server send events, and at the time of this recording, there is no built-in SSE library available. Therefore, I will need to use ABAP push channels to implement the communication myself. That's also the reason for using the current version 7.50. Previous versions only allowed for WebSocket push channels. I will also need some kind of internal model for my application, some place to store inventory data, register customers, track orders, and so on. I won't be using the SAP applications for this because they are not available in the trial version of the application server. Also, I'm not really familiar with that area of the system. Instead, I'll try to use the Business Objects Processing Framework, short BOPF, to implement my own model. Located somewhat between the device access and the model, I'll need some components that will actually do something, like deciding which order to fulfill next, selecting the storage items to be delivered, issuing the appropriate commands to the robot while keeping the model updated. While this will mostly be plain ABAP coding, I'm planning to use ABAP messaging channels to push the events that I've received and passed to this component. When the backend functions are present, I'll also need some kind of user interface. At the moment, I'm thinking of 4 user groups that will need a way to interact with the system. The system won't be fully automatic, so a machine operator will need some UI to get information about orders being processed and to confirm or correct deliveries. An assumed shift supervisor may want to get an overview of all orders and the complete inventory, with options of influencing the system in various ways. Some management level UI might also be interesting to provide performance information and statistics, and perhaps I'll implement some kind of customer UI to actually place an order. I'm planning to use different technological approaches for these UIs, again just to get some experience with the respective toolkits. At the moment, I'm thinking of a UI5 application optimized for touchscreen use for the shop floor, a more complex WebDyn Pro application using a toolkit called Floor Plan Manager for the supervisor. And since management level always needs the latest and visually most appealing applications, I'll probably be using Fiori for this. For the customer UI, I haven't decided yet. So as you can see, the big picture really has gotten quite big. At the time of this recording, I've already got the hardware built, both the Robo interface and the Photon are programmed, and I'm currently working on the cloud device access. If you're interested in the progress of this project, there are a couple of ways to keep up to date. I've created a YouTube playlist you may want to follow, But of course, you're also welcome to follow my entire YouTube channel. I can guarantee that you won't be flooded with information, not with a project of this size going on. I'll also be blogging about this on the SAP Community Network. YouTube won't let me make a link of that in the video, but I'll put the URL in the description. You'll find the articles in my personal blog as well. If you have any questions, suggestions, or would like to leave any other kind of comment, feel free to use any of these channels to get in touch. I'm looking forward to it. Thank you for watching and have a nice day.